We're going to start taking a look at how to graph and organize our data. And so in this first section, we're going to be looking at ways to organize and graph qualitative data. So just as a reminder, this was data that was usually non-numeric. So things like eye color or type of duck that we observe at a pond, or someone's social security number. Those are all examples of qualitative data. I picked social security number even though that's numeric. Remember, those numbers don't mean anything. They're just a way of assigning a way to identify a person. So even though it's made up of numbers, we wouldn't, for example, take like the average social security number. So that's something that's qualitative as well. So in statistics, one of the ways we're going to organize our data is using a frequency table. We're going to use these here for qualitative data, as well as again in the next section for quantitative data. So in a frequency table, we are going to list all the possible values of our variable of interest, and then the frequency, which is just a count of how many times each of those possible values occurs. And then if we add a column called the relative frequency column, then it becomes a relative frequency table, and I'll show you what that means as we do it in this next example. So what we're going to look at is a frequency table, and then we're going to add an additional column to turn it into a relative frequency table for a data set that I collected on color of M&Ms. So I just opened a package of M&Ms and counted how many M&Ms there were of each color. And so our variable of interest is color. Whatever our variable of interest is, we're going to make a column for that. Our next column is going to be labeled frequency, which is again just the count of how many times each color was observed. And so the colors of M&Ms are red, yellow, green, blue, brown, and orange. And I counted 7 red M&Ms, 3 yellow M&Ms, 7 green M&Ms, 11 blue M&Ms, 2 brown M&Ms, and 14 orange, for a total of 44 M&Ms in the bag. Okay, so that's an example of a frequency table. Again, we've got our variable of interest, we've got each possible value of that variable, and then the frequency for each value. So if we were going to turn this into a relative frequency table, we would just add a relative frequency column. And for relative frequency, we are looking for the frequency of occurrence of each of our possible values of our variable of interest relative to the total, so relative to the whole. So this is going to be written in fraction, decimal, or percentage form, and basically we're taking each observed value of our variable's frequency and dividing it by the total. So the relative frequency for red was 7 out of 44. We're going to go ahead and write that as a decimal also, so 0.159 if we round to 3 decimal places. Yellow is going to be 3 out of 44. Which is 0.068. Green is going to be 7 out of 44. We're going to come back and do the decimals in a second. All right, so for green, we're going to have there 7 out of 44, which is 0.159 again. Blue, we've got 11 out of 44, which is 0.25. Brown, we had 2 out of 44, which is 0.045. And then orange was 14 out of 44, which is 0.318. And so if we added all those together, we should get 1. We might get a little bit of rounding error, but it should be 1 if we didn't have any rounding error. Adding all those numerators, we would have 44 out of 44. All right, so that's what our frequency and relative frequency table look like. Now that we know how to do that, we're going to move into how to start graphing qualitative data. So there are a few different graphs for qualitative data that we're going to look at. The first is a pie chart, and this is probably familiar to all of you already. So we're going to start a pie chart with a circle. And then within that circle, we're going to fill in each of the segments with the proportion, which is the percentage here, of our colors. So this data set was for our color of M&Ms. And so I usually start with ones that are easy to recognize. So the 0.25 is blue. So for blue, we had 25%. From there, we had 31.8% that was orange. So I'm going to use that here. And then we had 2 that were at 15.9%. And those aren't looking like they're quite equal, but so let me do this. So let's make these the 2 that are at 15.9%. So we have red at 15.9%. We had green at 15.9%. And then we had yellow at 6.8%. And then we had brown at 4.5%. Okay, so as you can tell, as I went through there, you certainly don't have to make this perfect, but I do want to be able to tell that proportionally these are close to those percentages. I'm not very often going to be asking you to draw one of these, but more often to interpret. So for example, if I got another bag of M&Ms that had, let's say, 85 M&Ms in it, then I might ask you what percentage of those you'd expect to be orange, and we would say 31.8%. I might ask you how many would we expect to be orange, and that would be 31.8%, so 0.318 of the 85. So we would expect about 27 to be orange. Okay, so those are the types of questions that you might see there. Okay, we're gonna go ahead and continue here with a couple other types of graphs for qualitative data. And so the first one here is gonna be bar graphs. I'm moving my camera over a little bit for the sunlight there. So it says bar graphs are graphs for qualitative data where the horizontal axis represents the possible data values and the vertical axis represents a frequency or relative frequency. You can choose which one. And so each possible value of the variable usually has its own bar. And so what we said there, again, just kind of reading through, was that the horizontal axis would be our possible data values. And so remember, this was M&M color. And so those colors, as a reminder, were red, yellow, green, blue, brown, and orange. And then we would either want to make a frequency or a relative frequency axis for the vertical axis. This one doesn't say, so we can really pick either one. I'll just use frequencies. And if you look back at our M&M frequency table that we made, you can tell the highest frequency that we need is 14. And so we'll go ahead and go by 2s here. And then we're just going to make a bar to represent each color. So red, we had a frequency of 7. Yellow, we had a frequency of 3. Green, we had a frequency of 7 again. Blue, we had a frequency of 11. Brown, we had a frequency of 2. And then orange, we were all the way up at 14. All right, we would probably want to give this a title, like color of M&Ms, and then that's our bar graph. Okay. One more graph that we're going to look at in this video, and this is going to be quick and easy, which is a Pareto chart. And a Pareto chart is just a bar graph like we just did, but with our bars sorted from left to right, with left being the highest frequency count and right being the lowest frequency count. And so if we redraw the graph that we just did, we're still looking at M&M color. I'm going to call this still color of M&Ms. And we still are going to need frequencies up to 14. But the difference here is going to be that we're going to purposely choose a horizontal axis scale that goes from our highest frequency down to our lowest. So we could do that by just looking at the bar graph we just made, or we could do that by looking at the frequency table that we made earlier. So orange is going to need to go first, followed by blue. We're just going from highest frequency count down to lowest. Red and green can go next, and it doesn't matter which order we put those in. Followed by yellow, and then finally brown. Okay, so we had orange, blue, red, green, yellow, brown. And then we're still going to draw our bars like we did before. So orange was 14. Blue was 11. Red and green were both 7. And then yellow was 3. And brown was 2. Okay, so with qualitative data like we're looking at here, it really doesn't matter what order you place the value of the variable of interest, because that variable is non-numeric and could be put in any order at all. The only time that we're going to be picky about the order is when we're asked to do a Pareto chart.